Welcome back. Last lesson was the methodology, the 7 steps. Today we are at the bottom of the OSI stack where the wires actually live. Objective 5.2. Troubleshooting cable connectivity issues. Picture this. Trading floor, Monday morning. One desk has lost connectivity. Help desk reboots the laptop, swaps the dock, opens a ticket with the network team. Network team checks the switch. Port shows down. They escalate to data center. 6 hours later, somebody crawls under the desk and finds a chair leg sitting on the patch cable. 6 hours. One bent copper conductor. Layer 1 is the most common failure point in networking and the least respected one. Today we fix that. First thing on the bench, wrong cable for the job. Copper has categories. Cat 5, Cat 5e, Cat 6, Cat 6a, Cat 8. They are not interchangeable. Cat 5e tops out at gigabit. Cat 6 handles gigabit comfortably and 10 gig at short distances. Cat 6a is 10 gig over the full 100-meter run. Cat 8 is short haul 40 gig inside a data center cabinet. Plug a Cat 5 cable into a 10 gig port and the link will negotiate down, sometimes silently. The user gets a tenth of the speed they should and nobody notices until somebody runs a real test. Fiber is the same trap, different jacket. Single mode is yellow, narrow core, long distance used with laser transceivers. Multimode is aqua or orange, wider core, short distance used with VCSEL transceivers. They are not interchangeable. Mix a single mode transceiver with a multimode patch and you get a dim link or no link at all. The fix is not exotic. Match the jacket color to the optic on both ends. Now we get into signal degradation. First problem. Crosstalk. The signal on one wire pair leaks into the pair next to it. 2 flavors. NEXT, near end crosstalk, measured at the end you are transmitting from. FEXT, far end crosstalk, measured at the end you are receiving on. Causes are the usual suspects. Cheap cable, untwisted pairs at the termination. If you strip back more than half an inch and let those pairs lay flat, you have just built yourself a crosstalk source. A cable certifier will tell you exactly which pair is leaking and at what frequency. Next problem, EMI, electromagnetic interference. External noise from electrical equipment getting picked up by your cable. 4 common sources. Fluorescent light ballasts, electric motors, HVAC, elevators, garage doors. High current power runs sharing a cable tray with your data. And industrial equipment. Anything with a contactor or a VFD drive. Mitigation is shielding and separation. Shielded twisted pair, STP, for high noise environments. And keep your data cables away from power. A few inches of separation buys you a lot of margin. Third degradation problem, attenuation. The signal weakens as it travels. Every cable does this. The question is how much? The hard ceiling on twisted pair Ethernet is 100 meters. Past that, the signal drops below what the receiver can decode, and the link either fails outright or runs slow with errors. 3 things make attenuation worse. Length over the 100-meter limit, cheap cable, and too many connection points. Every patch panel and coupler in the run adds loss. The fix is the same in every direction. Stay under 100 meters end to end. Use better cable. Cut the number of patch panels in the path. Termination. If you crimp an RJ45 wrong, the cable does not work. T568A and T568B are the 2 pinout standards. Both are valid. Both work. The rule is pick one and use the same standard on both ends of the cable. Mix A on one end and B on the other, and you have just built yourself a crossover cable. Modern switches handle that with Auto MDIX, but older gear and some uplinks do not. If a cable tester reports a miswire, this is usually why. A cable tester reports 4 types of fault. An open, one of the conductors is broken or not seated, and the circuit cannot complete. A short, 2 conductors are touching where they should not, and current flows the wrong way. A miswire, the pinout on the 2 ends does not match. A split pair looks correct on a basic continuity test, but the pairs have been swapped between 2 of the 4 pairs. And the cable will fail at gigabit speeds even though it works at slower speeds. Every tester worth owning will distinguish these 4. The tester is your fastest path from quote the cable might be bad unquote to quote the cable is bad, and here is which pin unquote. Which tool you grab depends on the symptom. Cable not labeled, and you need to find which one in the patch panel goes to which port. That is a tone generator and probe, a toner. Tester says no continuity, and you need to know how far down the run the break is. Cable tester with length on copper or for fiber, an OTDR. Fiber link is up but dim, and you suspect a dirty connector, VFL first, then a fiber scope. Copper link runs slow and intermittent. Cable certifier, look at attenuation and crosstalk. Match the tool to the question. Do not pull out an OTDR for a labeling job. Speaking of which, your testing kit. 4 tools ranked by how often you reach for them. Number 1, cable tester. Continuity, length, basic faults. This is your daily driver, and a decent one is $150. Number 2, tone generator and probe. Finds cables in unlabeled patch panels. Costs nothing relative to the time it saves. Number 3, visual fault locator, VFL. Red laser through the fiber, lights up breaks and sharp bends. Cheap, effective. Number 4, OTDR, optical time domain reflectometer. Sends light pulses, measures reflections, tells you exactly where every event in the fiber is. Splice, bend, break. Expensive. Worth it for fiber-heavy environments. Not the first tool you grab. Fiber has its own special list of failure modes. 4 of them. Dirty connectors. Number 1 cause of fiber problems by a wide margin. Even a microscopic dust speck blocks light. Always clean before you connect. Connector type mismatch. LC, SC, ST, MPO. They do not interchange. You need an adapter or a re-terminate. Bend radius violations. Bend a fiber tighter than the manufacturer spec and light leaks out the side. Attenuation spikes. Link drops. Splices. Fusion splices have less loss than mechanical splices. If your link is dim and there is a mechanical splice in the path, that is the suspect. One scenario I have watched too many times. New fiber link will not come up. Engineer calls the carrier. Carrier dispatches a tech. Tech shows up 4 hours later. First thing the tech does, pull out a cleaning kit, wipe both ends of the connector. Link comes up. Bill arrives. The lesson here is the fanciest fiber tools in the world do not beat a $4 cleaning swab. Clean the connector first, always, before you call anyone. Cables also fail because the world is hostile to them. Temperature extremes. A cable rated for indoor use will degrade in an attic in summer. Water, runs through conduit, gets into connectors, corrodes contacts. Crush damage. Somebody rolled a server card over the cable. Somebody stapled it to a wall stud. Somebody walked on it for a year. And rodents. Mice and rats chew cable jackets. Sometimes the conductors. If a cable in a drop ceiling suddenly fails and you find tooth marks, you have a bigger problem than the cable. Quick recap. In the form of what should be in your cable troubleshooting bag. A cable tester, every time. A toner kit, every time. A fiber cleaning kit, every time. Even on copper jobs, you may end up touching fiber. A VFL for any fiber work. Spare patch cables in the most common categories. Spare optics if you are touching switches. And a label maker, because the next person who has to troubleshoot this run will thank you. And that next person is often future you. That is Objective 5.2. Cable problems are the most common, the most embarrassing when missed, and the easiest to solve when you have the right tool and the right method. Next up, Objective 5.3. Common networking issues, above the cable into the protocols. See you there.